Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the fifth part. In this part, we're supposed to determine the standard equation of the hyperbola. We're given the two vertices and the perimeter of the central rectangle. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Before we jump into this example, let's have a review on the parts, the two cases, and the equations of hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola, and it passes through the focus, and there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, A, B, and C, is C squared equals A squared plus B squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back to the problem right here, we are given the vertices. So we're going to go ahead and sketch these two vertices on the graph right here. So it goes 0 to 7. So this is our first vertex. Well, the other vertex is going to go across 0, -7. So these are the two vertices. Now we also have the perimeter of the central rectangle. Looking at this, we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. So in this case right here, the center between these two vertices, or the midpoint, would be the point of origin or at 0, 0. We can go ahead and say that that's the center right there. And furthermore, looking at this, these two vertices here are vertical relative to each other. So we can go ahead and say that this is an example of a vertical hyperbola with the center at 0, 0. So I'm going to go ahead and write that information up here. Okay, since this is a vertical hyperbola, we can go ahead and write the general equation of a vertical hyperbola, that is y squared over a squared minus x squared over b squared equals 1. Now we notice that this value of a is the distance from the center to the vertex. So we can go ahead and write that up here, that our a is actually, that's gonna be 1, 2, 3, 4, 5, 6, 7. So we can go ahead and rewrite this equation as... So please notice that I left the b squared blank because we don't have the b value. The b is the distance from the center to the co-vertex. However, we're given the perimeter of the central rectangle, which is 48. So we can go ahead and determine the value of b. Let's have the definition of what a central rectangle of a hyperbola is. So I have here this general hyperbola so that we can go ahead and determine how do we determine the b from the perimeter of the central rectangle. We remember that the distance from the vertex to the vertex is represented as the transverse axis. So this one right here will be counted as our transverse axis, while the distance from the co-vertex to the co-vertex is represented as the conjugate axis. So I'm going to go ahead and write that as CA right here. To get the perimeter of this central rectangle, then we go ahead and add the TA plus the TA, CA plus the CA together. So I can go ahead and write the general equation for the perimeter of the central rectangle of hyperbola right here. So P is equal to, that's going to be 2 times TA plus 2 times the conjugate axis. So that means the 2 TA here will be added together and the 2 CAs will be added together. That's the perimeter of this rectangle. Now we remember further that this distance from the center to the vertex is represented as A. So this one is also A down here. So we can go ahead and say that this TA is actually equal to 2A. So I'm going to go ahead and put that up here. So our TA is actually the sum of the 2A's. And the conjugate axis is actually made up of two b's. So the distance from the center to the first co-vertex is b, while the distance from the center to the other co-vertex is also another b right here. So we can go ahead and say that our conjugate axis is actually 2b. So we can go ahead and plug that in here. So that would be 2 times 2b. So there are two b's that make up the conjugate axis, and there are two a's that make up the transverse axis. So this is the formula that we have right there. So from here, we can go ahead and solve for b. So we plug the values in. So that would be p equals 2 times our a is 7. So we can go ahead and say 2 times 7 is 14 plus 2 times our b is missing. So we can go ahead and simplify this further. I just plugged in the a right there. So this would come out p is equals to 2 times 14 plus 2 times, or that's going to be 2 times 2 is 4, and then we got a b. And so we can go ahead and plug in the parameter, which was 48. So 48 equals 28 plus 4b. We subtract 28 from both sides. So minus 28 minus 28. So we can go ahead and say that our 4b is, we cross this out, is equal to 20. So to solve for b, we go ahead and divide this by 4. We divide this by 4. So then our b then is equal to 5. So this is our value for b. So we can go ahead and write that up here that our b is 5. We can actually go ahead and simplify come up with a better simplified equation for the parameter. That is actually p is equal to 2 times 2 is 4. So that's going to be 4a plus 2 times 2 is 4, and that's going to be 4b. So we can put this inside the box. This is a more general equation of the perimeter of the central rectangle of a hyperbola. So that we can go ahead and write that up here since our b is 5. So we plug it in. 5 squared would be 25. And so I'm going to go ahead and rewrite the equation for this hyperbola. So this is the equation for this problem that we have right there. So we go ahead and plot this hyperbola, the graph of this hyperbola. So we say that our b is 5. So I go 5 to the left and 5 to the right. And this will be our first co-vertex and the other co-vertex on the other side right here. So we can go ahead and write the coordinates of the two co-vertices up here. Okay, so we can go ahead and sketch the central rectangle. Okay, if you notice, the length of this side is, that's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the length of this side is 14. The length on the other side is also 14. Now the length from one end to the other end of the rectangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, the length of the other side is also 10. So if we add all these together, 14 plus 14 is 28. 28 plus 10 is 38. 38 plus 10 is 48, which is the perimeter of the central rectangle. So that we can go ahead and draw the asymptote for this graph. So the equation for the asymptote with a negative slope would be, that's gonna be y equals, we go up 1, 2, 3 from the center, we go up and to the corner of the box. So 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4, 5. 7 over 5x, and that's a negative because we went to the left. And so the equation for the other asymptote would be y equals, from the center we go up, that's 7 over, we go to the corner of the box, that is 5, and it's going to be positive because we went to the right, and that is x. We can go ahead and say that the length of the transverse axis is 14, while the length of the conjugate axis is 10. So I'm going to go ahead and write that work up here. Okay, so that we can go ahead and determine the location of the foci or the two foci. So we remember that the focus is located C distance from the center. So we have to go up C and down C. So we go ahead and use the equation C squared equals A squared plus B squared to solve for the location of the foci. So we go ahead and show that work up here. So we have the location of the C, which is 8.6 up and 8.6 down, or that is square root of 74. So this is our first focus. So that's 5, 6, 7, 8. 8.6 should be somewhere up here. So that's the first focus. Well, the other focus would be, so that's gonna be 5, 6, 7, 8.6 is somewhere around here. This is our second focus. So we can go ahead and write the coordinate of these two foci down here. So we can go ahead and sketch the graph of this hyperbola. So this is the equation of this problem right here, and this is the graph of this equation down here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're supposed to determine the standard equation of the hyperbola. We're given the vertices. That's going to be a negative 5 and 5. So we're going to plot this. Okay, now we remember that the center of the hyperbola is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So in this problem right here, our center or the midpoint between these two vertices is at the point of origin, or at 0, 0. And if you notice, these two vertices are horizontal relative to each other. So then we can go ahead and say that this is an example of a horizontal hyperbola with center at 0, 0. So I'm going to go ahead and write that up here. Okay, since we have a horizontal hyperbola, the general equation for horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. So let's determine the values of a and b. A is the distance from the center to the vertex. So in this case right here, our A would be 1, 2, 3, 4, 5. So I'm going to go ahead and write that up here. So A is equal to 5. So we go ahead and plug this A into this equation right here. I left the b squared blank because we don't have the b squared value. But then we are given the perimeter of the central rectangle. From the previous video, we have derived the general equation for the perimeter of the central rectangle of a hyperbola. And that equation is P is equal to 4A plus 4B. So that we can go ahead and determine the value for B from here. We are given the parameter, which is 44. And then our A is 5. So we plug it in. So 4 times 5 plus 4. And then the B is missing. So we keep that as B. So that we can go ahead and simplify this. That would be 44 equals 4 times 5 is 20 plus 4B. So we go ahead and solve for B. Okay, since our B is 6, we go ahead and plug that 6 in here and come up with the equation for this hyperbola. Okay, so this is the equation for this problem that we have up here. Now, since we say that our B is located, our value for B is 6, so then we can go ahead and say that we go up 6 and down 6 to get remember the B is the co-vertex. So I'm going to go ahead and plot those 2 points up here. Okay, so the coordinate of the two co-vertices is 0, 6 and 0, negative 6. So we can go ahead and sketch the central rectangle and the two asymptotes. Okay, now let's determine the length of the transverse axis, that is from the vertex to vertex, the distance between them, or the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. So I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 10, while the length of the conjugate axis is 12. So that we can go ahead and determine the location of the two foci. Since the distance from the center to the focus is C, we can go ahead and solve for C using the equation C squared equals to A squared plus B squared. I'm going to go ahead and show that work up here. So this is the graph of this equation that we have right here. Now we can compute for the eccentricity of this hyperbola, again using the equation E equals C over A. So I'm going to go ahead and show that work up here. So the eccentricity of this hyperbola is square root of 61 over 5. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!